Tervetuloa pagani ja tutot. Good morning, boys and girls. Today we will work on pyramids. Open your books to page 366. And we will work on first some definitions concerning our pyramids. The top of a pyramid is called what? An apex. And the bottom of the pyramid is, as we've already seen with prisms, called the base. So pyramids consist of a base and an apex and lateral surfaces. A pyramid is regular if its base is a regular polygon in which all the sides are of equal length. And a regular pyramid is right. You should put right in quotation marks because there's no right angle necessarily in a right pyramid, but the apex of the pyramid is directly over the center of the circle, meaning the altitude of the pyramid forms a right angle at the foot of the base. So from the apex to the base forms a right angle. This chapter is fairly unique because we don't actually have to derive on our own the volume of a pyramid. Instead, we're just given it because deriving the volume of the pyramid on your own, discovering that equation, is quite difficult. So the book just tells us the volume of a pyramid is 1/3 the product of the pyramid's height and the area of the pyramid's base. So this formula is very similar to our area of a prism formula. Let's go to our first problem. 14.8. ABCDE is a right square pyramid such that BC equals 6 and AC equals 5. So let's draw a pyramid and label it. BC is 6, AC is 5. Why is AO perpendicular to the base? We know that a line from the center of the base to the apex is perpendicular to the base. Thus, AOM is a right angle, and angle AOB is also a right angle, and so on for any point on the base. Let's focus on triangle AMC and find AM. Once we've discovered AM, we'll be able to find the missing side of triangle AOM. So triangle AMC. We know that AC is 5, and that's a hypotenuse, and AMC is 1/2 of, and MC is 1/2 of CD, and AMC is a right angle. So AC is our hypotenuse, CM is 3, and we'll just use our Pythagorean theorem. Now that we know that AM is 4, we can find AOM, and we know that AM is 4. What is OM? It's 1/2 of BC. Since these are all parallel lines and this base is square, that makes OM 3. So 16. So an AM is our hypotenuse, so that means 16 minus 9, which is 3 squared, equals AO. So AO equals the square root of 7. Now let's set up the equation for the total surface area of this pyramid. So the surface area of each of the side faces is going to be 4 times the area of any of these triangles. All of these triangles are congruent. So each of these triangles, so the total surface area will be 4 times the area of one triangle. So I'll say the area of ADC. plus the base of our triangle. What's the base? 6 times 6, 36. Alright. Lastly, what's the volume of this pyramid? How much water could this pyramid hold? So remember, our formula is the area of the base times the altitude, which is AO, divided by 3. So 36, 12 square root of 7. And that finds the volume, total surface area. We found AO, we found AM. So we've really dealt with this pyramid quite handily. Let's go to 14.9. Find the formula for the lateral surface area of a right pyramid whose base is a regular n-gon, the side length s, and whose slant height is L. Well, one thing you need to realize about pyramids is that they can have any type of base. Now, when we think of pyramids, we're used to thinking of the pyramids at Giza. They all have a base of the same regular shape. That's a square. But a pyramid doesn't have to have a square base. Some people will try and correct you throughout your life and say, well, a pyramid has a square base and a tetrahedron has a triangle base. And then you could ask, well, what's a hexagon base pyramid called? The lateral surface area of any pyramid is made up of triangles. And on a right regular based pyramid, all of those triangles will be congruent. So, we'll find the area of one of those triangles and multiply it by the number of faces. Thus, L, which is our altitude for one of our triangles, plus times S over 2 times the number of faces equals the lateral surface area for any right regular pyramid. In 14.10, we are given a regular tetrahedron. And a tetrahedron is made up entirely of triangles, triangle base, triangle faces, and all of these triangles are congruent to one another. You might also know this is a four-sided die. And our ultimate goal is to find the volume of this tetrahedron. But first, let's break this problem of volume into these 5 steps that the book gives us. First, what kind of triangles are AGB, triangle AGC, and AGD? Now, G here is our center of our base. Well, I already have it marked out for you, but we're told it's a right regular tetrahedron. And that means that A to G is perpendicular to any other point on the base. So each of those is a right angle. Now in B, we're given a hint. The book doesn't want to leave us totally unable to find the volume, and so a couple of keywords are given to us to help us out: circumcenter and centroid. Circumcenter of triangle BCD is also G. If you remember the definition of a circumcenter is a point that is equidistant to each of the vertices of the triangle, so that you might draw a circle which passes through each of those vertices. So G is the circumcenter, which means that GD equals GC equals GB. Then it's we're told that it's also the centroid. So why is it a centroid, and what is a centroid? Can you remember? An easy way to do this is, let's take the view from above. Let's look at triangle BCD from above. What type of triangle is it? Here on the left I've drawn it. BCD is an equilateral triangle. As you know, each side equals 6. And the centroid is the line drawn from a vertex of the triangle to the center of the opposite side. So this means that CBM equals MBD. These are both 30-degree angles. And each of these lines also passes through G. G is the centroid because we have created congruent triangles. What is BM and what is BG? We only know that these side lengths are 6. But we're dealing with a 30, 60, 90 triangle, and that might help us find BM. So since BMD is a 30, 60, 90, MD is 3, and BM is 3 root 3. But what is BG? How can we figure that out? Now this is pretty clever. It's something that goes way back about 150 pages. The centroid divides the centroid, that's point G, divides these lines from B to M into two parts, X and Y. What's the relationship between X and Y? If you remember, I'm not going to ask you to derive that all again, but if you remember, Y is 2 times X. But we don't know Y or X yet. Instead, we could find this by knowing that Y is 2/3 of BM. Right? Because if Y is 2, X is 1. In total, BM would then be 3. So Y is 2/3 of BM. Now that we know what BG is, we can find AG. That's the altitude of our polyhedron. We have a right triangle, BGA. We have one side, which is 6. Our hypotenuse is 36 minus 2 root 3 squared, which is 4 times 3. Square root of 24. It's 2 root 6. And now we have everything we need at last for finding the volume, because the volume is the altitude of AG times our base times CD over 2 all over 3. And you have the power to solve that equation now. Great job. That's the introduction to pyramids for today. Have a wonderful day.